One of the big things that you need to remember today is if the problem starts in radical form, your answer needs to be in radical form. If the problem starts in rational exponent form, your answer needs to be in rational exponent form. So whatever form you begin in, you need to end in that form as well. Sometimes we are going to be combining the radicals. Sometimes we are going to be splitting them up. Sometimes we are going to be changing into rational exponent form so that we can combine them and then putting them back into radical form. If you have the same index, you can combine radicals. If you don't have the same index, you cannot. So in this particular example, do these have the same index? No, so we can't combine them. But we can change forms. Square root of 16, how do I write that as a rational exponent? 16 to the 1/2. What about the fourth root of 16? 16 to the 1/4. Because these are both 16s, we can use our properties of exponents. If we're multiplying, what do we do with those exponents? We add them. So we take 1/2 plus 1/4. You can use your calculator for that, or if you bake very frequently, you probably know what 1/2 plus 1/4 is. That would be 3/4. So this is 16 raised to the 3/4. We can't consider this one to be done because it's written in rational exponent form. We started in radical form. So we do need to change this back into radical form. Do you remember how to do that? The denominator is the index. And the whole thing raised to the third. And then before you're completely done, you should check in your perfects chart to see if maybe we can actually evaluate this. So look in the fourths column. Do you see 16 in the fourths column? Yes, the fourth root of 16 is 2, and 2 to the third is 8. Now technically this should be plus or minus 2. So then our answer would be plus or minus 8. But in this section, they really don't care so much about that. When you're solving with radicals, they really, really care. Because if you put in that square root, then you have to consider the positive and the negative. This one, they gave us that fourth root, and they didn't put a plus or minus in front of it, so we don't really have to worry about it. So if they don't give it, if the radical's already there, you don't really have to worry about it. Okay, the next one. This time, are the index the same? Yes, if the index is the same, you can combine them. This is the third root of 25 times 5. What is 25 times 5? 125. Is 125 in the thirds column?
Yes.
It is. The third root of 125 is 5. The biggest thing for all of these is first check your index. If the index is the same, you can combine them. If the index is not the same, you cannot. In number 10, is the index the same? Yes. So this is the sixth root of 8 times 8. 8 times 8 is 64. Look in your sixth column. Sixth root of 64 is 2. Plus or minus 2. But the radical is already there, so it's just kind of implied that it's the positive. But if you wrote this on your paper and put a plus minus, I'd be like, hey, good job for remembering that. But if you didn't have it, I wouldn't count it wrong. Oops, if you're solving an equation and you put the radical into the equation, then you have to consider the plus minus when it's an even index. If the radical was given to you originally in the problem, then you don't have to worry about it. Does that kind of make sense, when to worry about it and when not to worry about it?
Yeah.
Okay. Yeah, sure. Totally, Miss Gilmore. Not at all, but it's okay. Okay. In number 11, they are both third roots, so you can put them under the same radical. And you can either simplify this fraction in your head, or you can use your handy-dandy fraction features on your calculator. 6/48 simplifies to the fraction 1/8. Okay, this particular problem is a little bit frustrating because this is not done.
Oh.
Your next step is to split it back up again. Now, how in the world would you know that you needed to do that? Honestly, look in the thirds column. In the thirds column, do you see that 1 and 8 are both in the thirds column? So then you'd split it up so you have the third root of 1, third root of 8, because we can actually calculate those. The third root of 1 is 1. The third root of 8 is 2. And 1/2 is certainly simpler than the third root of 1/8. In number 12, they do not have the same index. So let's change forms. The square root of 5 is the same as 5 to the 1/2. And the fourth root of 5 is the same as 5 to the 1/4. 1/2 and 1/4. What do we do with those exponents when we divide? Subtract. So 1/2 minus 1/4 is 1/4. So this becomes 5 to the 1/4.
How is 1/4?
So then you're thinking, all right, sweet, my answer is 5 to the 1/4. I'm done, right?
No, because you're dotting, so no.
Not because you know it's wrong, but because I'm dotting, so that means it can't be right. Yeah. What form did this problem start in? Radical form, so our answer needs to be in radical form. So the fourth root of 5 is our answer.
I'm blown away.
We're not going to go there for number 13 yet. Just not.
So that's not our...
For part 2, you definitely need your perfects chart. Do you remember back when I would give you something like the square root of 50, and we would split this into the square root of 25 times the square root of 2. The square root of 25 is 5, so this simplifies to 5 times the square root of 2. Do you remember kind of doing that with square roots? So we're going to be doing this with third roots, fourth roots, fifth roots, etc. Okay? It's really not that bad, I promise. This class is a little bit dramatic. So we have the third root of 54. We are going to split this into the third root of something times the third root of something. This first thing needs to be on the perfects chart. So this number needs to come from the perfects chart. That way we can actually evaluate it. So look in your thirds column at the numbers that are smaller than 54. The first number that's smaller than 54 is 27. So I would try in my calculator, can I do 54 divided by 27 and get a whole number? Yes, I can. That means that 27 times 2 is 54. So we're splitting 54 into 27 times 2. Both of them still under that cube root symbol. The cube root of 27 we can evaluate using our perfects chart. The third root of 27 is 3. So we have 3 times the third root of 2. Okay, I put some colors in there to help a little bit with where everything came from. Let's try the next one. The next one is the fourth root of 64. Since it's the fourth root, we're going to go to the fourths column, and we're looking for the largest number that is smaller than 64. 16. Hopefully, we can do 64 divided by 16, otherwise there's not going to be a whole lot of simplifying happening. What is 64 divided by 16? 4. That means we have the 4th root of 16 times the 4th root of 4. So these numbers go in your radicals. Okay. We can do the 4th root of 16. That's on our perfects chart. The 4th root of 16 is 2. Can we do the 4th root of 4? It's going to be some crazy decimal, so we leave that as the 4th root of 4. This is why I told you when you're writing these radicals, it's really important to tuck that index into the checkmarky part, because eventually we're going to have numbers times the 4th root, and we need to know that it's 2 times the 4th root, not 2 times 4 times the square root. You have to be very obvious about your index being your index. Okay, I want you to try number 3 on your own. Pause the video, try number 3 on your own. So these others were very, very obvious because it was the biggest number smaller than the number we were trying to break down. The biggest number in the thirds column, smaller than 10,000, is 8,000. And if you try to do 10,000 divided by 8,000, that's going to give you a decimal. All of them will give you a decimal until you get to 1,000. The third root of 1,000 times the third root of 10, because 1,000 times 10 is 10,000. The third root of 1,000 is 10. The third root of 10 we can't simplify anymore, so it stays the third root of 10. When you have the third root of a fraction, this is really the third root of 2 over the third root of 3. These are both very small numbers. There's no simplifying this. The problem is we are not allowed to have radicals on the bottom of a fraction. That is called an irrational denominator. You can't have an irrational denominator. We need to rationalize it. We need to make the radical go away. The only way to make the radical go away is if we had the third root of something in the thirds column. So what I want to accomplish is I want this thing to be the third root of something that is on the perfects chart. So look in your thirds column. Can you see any numbers in that column that we could maybe turn 3 into? 27. So that is going to be our goal. Our goal is to get the 3 to turn into a 27. How do you make 3 turn into 27? Times 9. So we multiply by the third root of 9 on the bottom and the top. The third root of 9 divided by the third root of 9 is 1. We're multiplying this fraction by a fancy version of 1. On the top, third root of 2 times the third root of 9 is the third root of 18. On the bottom, the third root of 3 times the third root of 9 is the third root of 27. That's our goal because we can evaluate that. What is the third root of 27? It is 3. And on the top, we can't really simplify the third root of 18. There aren't any numbers smaller than 18 on the chart that we could split 18 into. So we have the third root of 18 over 3. That is our rationalized answer. We cannot have the fourth root of 8 on the bottom. That is bad. We need to multiply the top and the bottom by the fourth root of something so that we end up with the fourth root of something that is on our chart. So think about 8. Look in the fourths column. Do you see 16 in the fourths column? Can we make 8 become 16? By multiplying by 2. So this is what you multiply by. 8 times 2 will give us 16. On the top, the fourth root of 7 times the fourth root of 2 would be the fourth root of 14. So we have the fourth root of 14 over, what is the fourth root of 16? 2. Try the last one on your own.